this too, is you have 2, 1, 2, 2, 2, 3, due Sunday, 9/21. So those of you that have not even started these, guess what? You don't get to watch football this weekend. There's no UTSA, there's no UT, no big deal. All right, so get it done Saturday so you can watch football Sunday. 10-6, Chapter 2 test. I probably will give you some kind of, I told you that I don't really do reviews, and I don't, but I probably will give you something maybe this weekend to kind of at least tell you you're going to have to do something. Well, I can tell you one question will be like what you take on the quiz today. Okay, but at least that way you're not studying junk that you don't need, you know. I don't know, well, I don't know yet. I was going to say I don't know that you'd have a sandwich theorem one. You know, maybe, we'll see, but I'll let you know whether you do or not. All right, so the very last thing we did in class was the proof of this limit. The limit of sine theta over theta as theta approaches 0 equals 1. Remember? Yes. Okay. And this is where I mentioned that for some of you, that's good. There it is. You're going to use it. Okay. If you didn't really understand the proof, I'm not saying that's the end of the world. Might be helpful. In fact, I had a student come into my office and we went over the proof again, and it like a light bulb went off. Or as you know, it's recorded. It's good to understand these proofs because it kind of helps you with solving problems. So what we're going to do is we're going to use that to prove the limit of cosine theta minus 1 over theta as theta approaches 0 equals 0. And a lot of these proofs, you know, yeah, of course, most of you are not going to go out and do proofs in the real world, but it's getting the logical part where you can actually logically solve something like, again, you're going to do on the quiz today. All right, so remember all we've done so far is said, can I plug in 0? No. Can I factor anything? I don't see anything I can factor. And then we did something with a conjugate. Well, I could multiply this by 1, meaning I could take the limit as theta approaches 0, cosine theta minus 1 over theta, and multiply this all by the cosine theta plus 1 over the cosine theta plus 1. So that's what I mean by the conjugate. And now your question would be, how would I have known to do that? This is just like what you did with identities. How did you know how to do stuff? You tried stuff. After a while, you work enough of these, you start to see patterns, like this would be a pattern of something you would do. Okay? All right, so now trying to remember, hopefully, some of the stuff in pre-cal. If I multiply, in other words, I'm foiling this, okay? Hopefully, I can convince you that that's cosine squared theta minus 1. Okay, so all I did was foil the top. If you remember when we did, what happened?
Is that sine squared?
10 squared.
Sine squared. Sine squared.
Cosine. I said sine?
No.
No, he's asking if it's equal to sine.
You just ruined the whole ta-da! Man, I'm just leaving now. That was my big question to see if you remember. Yes, good job. We'll get there in a second. All right, so if you remember when we did conjugates last time, I said leave the denominator alone. Don't multiply it out ever until you have to. What do I mean by you have to? Maybe the end. And the reason why is my eyeball is saying, I sure hope something can cancel that out, because if so, then I can plug in my 0. So now that it's been ruined, hopefully you remember sine squared theta plus cosine squared theta equals 1. So what I'm going to do is I'm going to solve this for cosine, meaning this is going to be 1 minus sine, and that's this next piece that I'm writing. So this, ooh, isn't that awesome? Don't know how I did that. Go away. All right, so this equals, I think I can get this to squeeze in here, 1 minus sine squared theta minus 1. So that's that minus 1. Okay, so in other words, I just threw that over there. And then theta goes to 0 all over theta cosine theta plus 1. All right, now you see that so nicely. And probably an extra step doesn't matter, but when we get into larger problems, I always bring, I factor things out in the front that I can, like numbers, negatives. So I'm going to just take this negative sign right there, and I'm going to throw it out front, just so I don't lose track of it. And I'm going to divide that sine square into two pieces. Uh-oh, I told you I was going to move it out front. So minus my limit as theta goes to 0. I'm going to separate that into sine times sine. So it's the same thing as sine squared. All over theta cosine theta plus 1. And I hope your mind went to, aha, that piece equals what?
1.
I mean 1. Yes, so in other words, I have minus my limit as theta goes to 0. That's 1, so we're just going to ignore it. Sine theta over cosine theta plus 1. Can I plug in 0 now? Yeah, nothing wrong. And that's all I'm doing, is I got to the point where I can now plug in 0. And let's do it in steps. Most of you already see the answer 0, because the sine, if I plug in 0 here, that becomes 0. But just to be complete, the cosine of 0 is 1. But of course, this is going to equal 0. Just did an extra step there to make sure you got those steps down. So when you have something like this, you know, again, you're in the perfect math world that we will say, use this limit to prove this. So you would have been told that. And so your mind says, somewhere in here, I need to come up with this, and I've got to figure out how I'm going to do that. So again, and it was good that you recognized that right away. You remember that whole sine squared cosine thing, and that got me a sine in there. So that was the perfect way to do it. All right. So, and if you want to be like all technical, you should say, therefore, the limit of the cosine theta minus 1 over theta as theta goes to 0 equals 0. And so thus you have proved it. Now in your homework, they're going to give you problems that are going to look more like this. It's going to say, show the limit of sine of 2x over 5x as x approaches 0 equals 2/5. All right, for those of you that are looking at this, says, well, that's easy, because all I have to do is do that, cancel the x's. That's a big no, 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 no. In other words, you're telling me that you can do this. F of, don't write this down, f of x over 3. You're telling me that's okay? That's a big no, 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 no. Okay? This is inside a function, so you can't cancel those x's. But on your homework, you're going to recognize you're going to be able to just write the answer. You know, because you're going to be able to see it. We're going to see that it equals, it's going to end up equaling these numbers. But with an actual proof, let's see, or a show, let's see how. So what you do is you take this limit, sine 2x over 5x as x approaches 0, and you multiply it by 1, that piece over there on the right. What do I mean by 1? 2/5 over 2/5. That's 1, right? Okay, so I haven't changed anything. And so whatever it equals, I'm multiplying by that. Now I'm going to take this 2/5 and bring it out front. Remember I said whenever you have numbers, bring them out to the front. So this equals 2/5. Limit, am I going too fast? I see y'all like really writing. Yes, no, you don't want to talk to me? Fine, I'll keep going. Okay. All right, so sine of 2x over 5x. That piece, remember when you divide a fraction, you flip and So that's this bottom piece right there. I just flipped it and multiplied. So that's okay? Then my 5s will cancel, and I'm left with 2/5 limit, x goes to 0, sine 2x, multiply those over 2x. Doesn't that sort of look like our definition if I let theta equal 2x? I can call 2x anything I want. I can call it Bob. Okay, let's call it theta, because then when I rewrite this, sine of theta over theta, we know that that piece right there equals 1, and thus 2/5 times 1 is 1. I wouldn't care if, like on a test or something, you actually define that. I mean, it's the proper way to do it because this is our actual definition. But if these values are the same, once again, who cares if it's the sine of Bob over Bob? Okay, it's going to be the same thing as Bob goes to 0. This whole piece is going to go to 1, and so thus this equals 2/5. Okay, so again, as you can see, you could have answered it just by looking at it, but that's not the correct way to do it. Okay, and of course it wouldn't always work if I had something more complicated up here in my functions. All right, one more example. Every time you cough, my throat hurts. All right, so find the limit as t goes to 0 of tangent t secant 2t all over 3t. All right, once again, finding limits. I hope when you're finding these limits, you know what you're doing, okay? Meaning, if I go back up here, and if I actually graphed, I put in my calculator, or whatever you're going to use to graph, I actually graphed that function, and I looked as x was approaching 0, I would see my y value is approaching 2/5. And that's why I'm going to make you graph today, because I'm hoping you recognize that. That's what you're doing. You're saying this function here, as I get close to 0, and let's just use x's, we're more comfortable with x's. As my x-axis is approaching closer and closer to 0, what is my y value approaching? That's all the limit is. That's all you're doing. Okay, so you might say, well, why don't I just graph it and I could get my answer? Well, you could, but something like this, again, my math lab, you wouldn't get exact values. So what I told, and I'm gonna do an extra step here, is I'm gonna break apart all of these pieces. Okay, this is probably an extra step that most of you don't need, but I'm gonna go ahead and do it in these 3 pieces. What I told my pre-cal students all the time is when you're doing identities or doing anything in pre-cal, put everything in terms of sines and cosines. And a lot of the reason why is, I mean, most of you probably don't even remember what a secant looks like. I mean, most of the pre-cal teachers do sines, cosines, tangents, and that's pretty much it, okay? And so if I put all this in terms of sines and cosines, what's tangent? Sine over cosine. What's secant? 1 over cosine, and that's 2t. And then I still have that piece there. Oops, wrong button. All right, now, I said earlier, whenever you have numbers, throw them out front. Okay, so I'm going to have 1/3, my limit as t approaches 0. I'm going to take this, because these are all being multiplied, and I'm going to put it over t. Hopefully, when I do that, you say, aha, there's my 1. And then I just multiply all these pieces that are left. So this becomes my 1 over cosine, and my 1 over cosine 2t. Cosine 2t. I know that that is 1. Can I plug in my zeros now? 1 over cosine of 0 is 1. 1 over cosine 2 times 0, cosine of 0, still 1. There's your answer. So all I'm doing is this piece went away, that became 1, and I'm plugging in zeros here. I'm finding what's the cosine of 0, which is 1, 1 over 1, which is 1. What's the cosine of 2 times 0, which is the same thing as the cosine of 0, which is 1. And 1/3 times 1 times 1 times 1, and you get your 1/3. Okay, so when you see something like this, I would split it up and then start to write everything in terms of sines and cosines. I mean, especially sines, because that's what you're trying to do. You always tell students, you know, it's kind of funny because if you're in section 2.4, what do you think you're doing? You're using that definition. So apparently that's what they want you to do in this actual section.